We're going to do our second example here of an RLC circuit, but first I would like to talk about the wall. But what I mean by the wall is the plugs in your wall, the electric plugs in your wall. A socket in the wall is AC current, alternating current. What it is it's a sine wave or a shifted sine wave, but a sine wave with frequency 60 hertz. I'll show you how that shows up here, and an amplitude of 100 volts. So the 100 volts shows up like that. Sorry, the 110 volts, not 100. The hertz, the 60 hertz, shows up in that, remember, period is 1 over the frequency. Or I could flip it and say 1 over the frequency is the period, right? So remember, period is how long this cycle is, right? So if I flip cycles per second, I get seconds per cycle, right? So I get t equals 1 over 60, and then that's seconds per cycle. And then what that is measuring is this distance. That's one cycle. How many seconds is it? This tick right here on the x-axis or on the t-axis would be 1 over 60. So when we have our sine functions, we do sine of something t. And we need to figure out the something that goes there to make it so that it matches this plug for a wall. So we'll often use an omega for that. It looks like a W. And remember, period is 2 pi over omega. So remember, the period is 1 over 60. So what I can do is say 1 over 60 equals 2 pi over omega. Then I can cross multiply, and I get omega is 120 pi. Now, this is where I guess you sort of use some sig figgy things, right? But that's almost 377. So that's approximately 377. Sometimes we will write it with 120 pi, and sometimes we'll write it with 377. But I wanted you to see that number because it sort of seems like a weird number, and it shows up in some of the book problems, and I'm going to use it in this example right here. So I'm going to pause and put the circuit up, and we will solve for the current going through it. So here is our circuit. I got an E of t that is 110 sine of 377 t volts. I have a resistor that's 100 ohms, a inductor that is 2 henries, and 5 times 10 to the negative 6, which is 1 over 200,000, is the measurement of the capacitor. So we are going to use, I'll write it here, Li double prime plus Ri plus 1 over C times I is equal to E prime of t. So the first thing that I need to do is actually find the derivative of E of t. So E prime of t is equal to, well, if I take 110 and multiply it by 377, I get 41470, and then there's cosine because of the derivative of the same 377t. So that's going to go right here. And then the resistance goes there. The inductance goes here. And the capacitance goes here. So when I do that, I get 2I double prime plus 100 R, it means to be a prime there, I'm sorry, R 100I prime plus, this is easy to flip, 1 over 200,000, divide, I just get 200,000, which is a massive number. I equals the 41470 cosine of 377t. So let's divide everything by 2, and then we'll get going with solving this. Oh, no initial conditions here. We're just solving for the, we'll just do the undetermined coefficients work for this thing. So we can leave C's in there. All right. Divide by 2, I double prime plus 50I prime plus 100,000 I equals, divide that by 2, and I get 20735 cosine of 377t. Now, I'm going to do some rounding here, but we'll worry about it when we get to it. All right, so notice it is, I need to find my IC first. The IC is the part with the C's in it. So, r squared plus 50r, and I'm going to complete the square in one jump here. All right, 50 divided by 2 is 25. Square that, I get 625. And then I'm going to take the 100,000, move it over to the other side, or I guess what 100,000 plus 100,000 is what plus 625? Well, the answer is 99375. So I'm going to move that over to the right side. Equals negative 99375. So from here, square root, I get, or sorry, do the square, r plus 25 squared is equal to, same thing. And then square root, and I get r equals negative 25 plus or minus, and it is 315.238 times I. So when I'm doing my frequency for the IC, I'm just going to take 315. I'm fine if you have these gigantic numbers and round like that. All right, so IC is then equal to e to the negative 25t times C1 sine of 315t plus C2 cosine of 315t. So now I got to do the undetermined coefficients work, and this is where it gets, you know, big numbers, but nothing different from everything we've been doing. So IP is equal to A. Let's go up here. Look, I got this 20375 cosine of this, so I got to have sine of that and cosine of that. So sine of 377t plus B cosine of the same thing. Oops. IP prime is equal to 377A chain. Actually, you know, I'm going to pause and we'll see if we. I'm just going to write it all the way out. It'll be easier that way. So I get 377A cosine of 377t minus, because of the cosine's derivative, 377b sine of 377t. There are ways to like use variables instead of the 377, and I usually teach it in both ways, but this works just fine here, and we're going to do it that way. IP double prime is equal to, all right, here, I'm just going to write negative 377 squared, because there's going to be two of them. I'm not going to do that in my calculator, because I'm going to put it in my calculator and RREF it eventually. So A, and then sine of 377t, and then this guy's negative, same squared, B, but now a cosine of 377t. Okay, so now I need to fit it to the equation. So I'll go grab that. What is it? This one right here. You could fit it to either one, actually. You could do this one or the one above it. I'm going to get the whole thing. Here, hold on. So now I'm going to plug it through into the orange equation there. I'm going to do a little shorthand that I used, I think, in class the other day. I'm going to write, all right, 377a, or sorry, squared. That's this term. because I got to do 1 times this, 50 times this, plus, what was that, 10 to the 5th? I'm just going to write 5 zeros, that times this, right? I think it's 10 to the 5th, right? Yep. Okay, so 377a squared is going to get multiplied by a sine of, right? So that is this whole term right here. I'm just going to write sine of and cosine of just to make it easier to fit everything here. Minus 377 squared b cosine of, that's the second line, plus, now what I'm going to do, this is the 50 times line. So if you type in 50 times 377 in a calculator, you get 18,850. Let me check that. So that is this term. So it's that times a times cosine of, and I'm just going to write of, right? Minus same thing, 18,850, and then b, and then sine of, and then I'm going to have to go down to the next line, plus, and then this one's easy because it's just 100,000 times each of those. So 10, a sine of, and then plus 100,000, b cosine, of. And then that is equal to 20735 cosine of, like that. So I'm going to build out, well, okay, I'm running out of time, but I'm going to build out my matrix. I'm going to give myself actually a little bit more space. All right, so I've got a 0 line and a 20735 line. This is the cosine, this is the sine. I need A terms and B terms. So I'm going to color code some things. I'll underline all the signs. 1, 2, 3. So notice A has a 377 squared and 100,000. So I'm going to write 377 squared plus 100,000. When you're filling out your matrix in your calculator, you can just type that in and it'll give you that number. So for B, I'm going to get negative 18850. And for this column, I actually wind up getting, well, got this 1850 and that guy. And look here, I actually messed something up here. Do you see this? That's got a negative. So that means this needs a negative, and that is a negative. So I'm going to pause, and I want you to pause and REF it. We'll make sure you get the same things. So when you do all this math, you get this number and that number in these two entries. Negative that, positive, same thing. 02035, you REF it, and you get these guys right here. And then those becomes the A and the B here. And then I will add it to the IC. So give me a moment and that will pop up. To get this massive equation, I of t equals blah, 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 blah. That's the XC plus this times sine of 377 plus this times cosine of 377. Now, I will take a very short moment to talk at least a little bit about what I think I know about electricity. This is called the steady state solution. What is that? Every electric circuit, when I hit it with something like this, falls into a steady state solution where the current always does the same thing. If you look here, no matter what the C value, there's an exponential decay here, and it's a massive exponential decay. So this piece right here, it goes away, and it goes away very quickly. And then this circuit falls into a state where it does this thing for forever. So the steady state solution is what is studied a lot in electronics, and that's why this undetermined coefficients strategy is super important for dealing with electricity. So thank y'all, and appreciate you. Bye.